Hi everyone, we're going to be filling out a quick part of our toolkit on exponential functions. It's just a little half sheet, so we'll glue it into your comp book in just a second, but let's fill in what we need to know. So we have in bold what an exponential function looks like. This is the general form of the exponential function. We have a few parameters, as you might see, right? Those are the letters that describe the function. They are not the input or the output, right? They're the other pieces. In our previous function families, a lot of the parameters were h, k, and a, right? Those were the big parameters we were looking at. Now we have a and b, so we're going to describe what those represent and then talk a little bit about how we know something's growing versus decaying. So first off, a, if you just want to draw an arrow, and a is going to be the starting value. So we're going to look at the spread of disease today, so you can think about the starting value as the number of people originally who had the disease. Some of you might be familiar with that term, patient zero, the first person. So oftentimes our starting value will be 1 if something's growing. B is going to be the growth or decay factor. And you'll notice those two words correspond to the two boxes down here. If something is growing, we are going to see that that value, B, is going to be greater than 1. If something is decaying, we are going to notice that the B value is less than 1. So pay attention to that, and that'll help you identify what type of exponential function it is. And X is going to be the input, right? So is the input. Oftentimes, we're going to think about X in this unit as time. So the time is what the growth is dependent on. Over here, f of x, this is the output, right? And this is the resulting value. After something has grown or decayed for a certain period of time, it's going to give us f of x, and that's what we're going to get out of it. On your previous page, or in your comp book, you have the paper folding activity that we did last class. What I would like you to do now is go back into that activity, open it up so you have those two graphs, and write an equation for them. So if you have your paper folding activity opened, you should have your table. Mine isn't filled in, but you should be filled in. The situation, so describing what's happening to the paper, your graph from last time. And now that we know a little bit more about how to write equations, we're actually going to add our exponential equation. So let's write f of x is equal to, and go ahead and fill that in. Use the pink sheet that we just filled out to help you with that. This is the growth, so think about what does b have to be for it to be growing, and what is it growing by, right? What is it being multiplied by each time? For the second part, you can see this is a decay, right? It's getting smaller, so we want to think about what is it being divided by each time? How fast is it getting smaller? Again, look at that pink toolkit a slip that we just filled out to help you with that equation. So take a second to do that. Once you have your equations down, turn to the people at your table, compare what you have, and make sure you have a really solid equation to match your table, graph, and situation.